Here we're going to look at a formula we need to be able to use our calculator to solve or evaluate any logarithms and solve any equations involving logarithms in actually any base. But our calculator only has log in base 10 and in base e, so it seems we're sort of restricted just to be able to solve equations where the base is e or 10, and that's actually not the case. So first thing to remember is that the calculator has a log and an ln button. But in fact, we could only use one or the other. If our calculator only had one or the other, it would still be fine. But it has the ln button because log in base 10 and log in base e is very common. Log in base 10 is common, so they've put those two buttons. Okay, buttons. So, but the question is, how do we calculate using our calculator something like log in base, I don't know, 19 of 2, right? So what are we solving when we're doing that? We're trying to find an exponent, so that's the log, to which we raise 19 in order to get 2. So obviously this is not something that I can estimate what x is, I know that it's definitely going to be less than 1, because 19 to the 1 would give me 19, and 19 to the 0 will give me 1. So it's somewhere between 0 and 1, but otherwise it's probably closer to 0 than it is to 1. But apart from this, that's pretty much all we know. So how do we use our calculator to evaluate something like this? So this is the change of base formula, which we've seen in the previous course, but I'm gonna go over it again. Okay, so say y is the log in base b of m. Okay, then written in exponential in an exponential equation, this reads y is the power or is the exponent, sorry, to which we raise the base b in order to get m. Okay, now what I'm going to do, so b to y is equal to m. So remember that logarithmic functions are one-to-one, right? So if I've got log of a, which is equal to log of, actually maybe I should use x and y. Let's say log in base b of x is equal to log in base b of y. This is equivalent to y equals x, right? But I can use this in any direction. I can use it to go this way and get rid of the logs and just get y equals x. But I can also use it this way. So if I've got x equals y, I can take logs on both sides and that's still equal. So this is what I'll be doing here, using the equivalence, but in this direction. So now what I will do is take the log in base a on both sides of this equation. So I'm going to take this equation, take the log in base a on both sides. So I'll get this. Ultimately, a, for our needs, is going to be either e or 10. Okay, so we're going to be taking log in base 10 or log in base e. But to cover both, I'm just going to write log in base a. Okay, so a here is going to be typically 10 or e. Okay. So now I've got log in base a of b to the y is log in base a of, not b to the y, but of m. That's what I want to write here. Okay, and now I'm going to use the property which says that I can send the y in front of my logarithm. It's not y equals, y times log in base a of b is equal to log in base a of m. And let's remember what we're really trying to do here. We're trying to calculate this y, this log in base b of m. So I'm going to solve this expression for y. So y is log in base a of m, or over log in base a of b. And that gives me the identity that I want. So if I want to calculate log in base b of m, I can convert that to an expression where I'm evaluating the log in another base. And this other base will be a base that I have on my calculator, either e or 10. So I'm going to be calculating log in base a of m over log in base a of b. So just to show you how that actually works. So this is our change of base formula. Okay, so let's write it here. Change of base formula. So I'll just give you two examples here. I want to evaluate log in base 7. Well, what was our initial problem? 19 of 2. Okay. So I can use log in base 10. Okay. In my change of base formula. So in which case a would be 10. Let's write 10 actually, so that you can see that a is I've replaced a by 10. So it's log in base a of m over log in base a of b. So this is basically on my calculator log of 2 over log of 19. So I will calculate this immediately. So log of 2 divided by log of 19. That gives me, remember, I was expecting something between 0 and 1, a bit closer to 0 than to 1. I get approximately, with 3 correct digits, 2, 3, 5. I can check or verify that this is correct because the log I'm trying to find, or I found, is the exponent. So 0.235 should be the exponent to which I raise 19 in order to get 2. So this should be very close to 2 if I calculate it on my calculator. So 19 to the 0.235, and that turns out to be 1.998. And yes, so the idea was to get something close to 2. So of course I don't get 2 exactly because this has been rounded off. Okay, but if you type in your calculator 19 to log in base 2 over log in base 19, you're going to get exactly 2. Okay, so we're going to do a quick example here. So let's say I want to solve 7 to the x equals 8. Okay, so what do I want to find? I want to find an exponent, okay, which is the exponent to which I raise 7 in order to get 8. So I'm trying to find log in base 7 of 8. Now, just to make things slightly different here, I'm going to use my change of base formula with log in base e. Okay, so according to my change of base formula, it's going to be log in base e of m over log in base e of b. So this is going to be ln of 8 over ln of 7. And if I calculate this with my calculator, this is going to give me roughly this. And you can verify that this actually works. If you raise 7 to that exponent, to that power, you're going to get 8.01. So maybe if you want to go back to the change of base formula and write it so that it can be used practically, the idea is that to evaluate log in base b of m, you can either use the log button on your calculator, or you can use the ln button on your calculator, like that. Okay, so practically these are the equations we're using to calculate things using our calculator. So on a calculator, you'd be using those two. Calculator. And doesn't matter whether you use log or ln. If there's a button, if ln is hidden somewhere, okay, as a second function, okay, and log is readily available directly as a button, just use log. Okay. And that's it for this section. So in the next week, we're going to use also these properties to solve logarithmic equations.